G'day and welcome back to Buildsum, and this is part 3 of the series on calculating wall bracing. And in this video we're going to look at determining the end elevation and then calculate the racking force that our wind loads are going to put on our building. Okay, so we're going to look at wind direction 1 first, which is blowing onto the long side of our building. Okay, so this is the elevation of our building. Now, the table, at the top of the table, there's a little diagram, and it points out that you don't have to work out the whole wall elevation. You only have to calculate from halfway up the wall. Okay, and there's also a little note at the bottom of the page there somewhere that says that you don't have to worry about the eaves. Unless they stick more than a metre past the outside of your wall, you don't have to calculate the eaves as well. So that yellow area there is basically what we're going to calculate in this little step. So a bit of information. So the roof pitch is 30 degrees. We know the building length. We know the width. It gives us a half span of 3.635, which you'll see why in a moment. And our wall height in this case was 2.7. So to work out the elevation of the wall area, this half of the wall, we're just going to go the length of the building times by half the wall height, which gives us an area of 20.034. To work out the roof, what I do is instead of trying to work out these separately, I'm basically going to cut this triangle off and stick it on over here and make this one rectangle. Okay, so this length here is the length of the roof minus the half span of the building. Okay, so the length of the roof minus the half span gives us 11.205. The height of the roof, okay, because our pitch is 30 degrees, it's tangent 30 times the half span. That gives us the rise of the roof. So that gives us 2.099. And if we times those two together, 11.205 by 2.099, it gives us an area of 23.519 for the roof. So then we add the roof and the wall together. That gives us a total area of this elevation of 43.553 meters squared. Okay, so we'll stick that in a little memory bank somewhere. We know that area. We can then do wind direction 2. So at the short end of the building, similar process. We only have to work out half the wall and the roof. Don't have to worry about the eaves. So same information. So to work out the wall length or width of the building times half the wall height gave us 9.815. To work out the roof, I've done the same as what I did before. Cut this bit off, stick it over here, make it a rectangle. So the length of the building minus the half span gives us the same number, 3.635. We already know the height of the roof from our previous calculation, so 2.099. So times them together, we get a total area of our roof of 7.063 square meters. So the roof plus the walls gave us a total area for wind direction 2 of 16.878 square meters. So now we know the areas of our elevations, we can calculate the racking force. So remembering from the previous video that we had a wind direction 1 had a wind pressure of 1.1 kilopascals. Our area of elevation is 43.553. We times those together and we get a total racking force acting on wind direction 1 of 47.908. So that's basically kilopascals acting on that area. Okay, and then we do the same for wind direction 2. Wind direction 2 had a pressure of 1.2 kilopascals. Times that by our elevation, that's the area of our elevation, 16.878. Okay, it gives us a total racking force on wind direction 2 of 20.254. So now we know what the force is that's acting on our elevation. In the next video, we can start to look at getting enough bracing into our building to actually resist that force.
G'day, I'm back. Just to let you know that if you like this video, you can subscribe to my YouTube channel or you can follow me on Facebook so you don't miss out on more great videos.